Welcome to Malini Bhandaru, who is the IoT lead for the open source and being part of VMware. My my thing is I came across her as in 2012 or 13, I believe, at Yahoo when we met. So we started OpenStack together, and this is the time when we are moving to the open infrastructure, and then from there, correspondingly, we are looking at edge computing and IoT, which is big. So what I want to see is her background. She's from IIC Bangalore, and her background in Intel is known to everybody. She has led several people and helped people in the edX Foundry off late, and Open Daylight. She used to be part of OpenStack. So the things go on. So more than 20 years plus PhD plus, I think, I don't know how many patents, 8 patents. I don't know.
No,
There
about
are
20.
20 patents.
20
Okay.
or more.
Yeah. Sunku had 8, so you have 20. so yeah, so not only just academic and research, but also at the level where you have the skill set, and she has been the proponent of women in OpenStack. So we are very happy to see that we have two keynote speakers as women, and we like to encourage, and that is the reason why Malini is here. And with that, I'll stop because there is a lot more to say. Let her share what she wants, and let's hear her. Thank you. Welcome. Go ahead.
Thank you. Thank you. It's an honor to be here. And I'm going to make my talk about 30 minutes so we get back on track for time. And there won't be any loss, that I'm sure of, because we can always catch up on LinkedIn or other modes. So I'm expecting an audience that's about 1/3 students, 1/3 academics, and 1/3 startup people. So even one person in each is fine. So the talk is going to be paced for that. So let's start with the students, and let's hope we have some students listening in. What's IoT? Where do we use it? What's the market size? We'll cover some architecture, the software that's available, and what we can do in terms of innovation. So IoT is all about the fourth industrial revolution, and it's because right now we have so much resources, so much since the time of my PhD. We have cheap storage, we have cheap computing. I mean, the cloud is ubiquitous. We have awesome networking. We have so many ways of networking too. I mean, you can do Ethernet, you can do Bluetooth, you can do Wi-Fi, which makes possible an endless array of applications, and it's really your imagination. So the kind of market we're looking at is billions of dollars, and it's just growing and growing. Do we have echo? Sorry. So this is just an indication of how large this is. It's growing at a CAGR of 23 to 26%. It's trillions of dollars. And even if you don't think of it at trillions of dollars, it's billions of dollars. And it transcends the space of finance, healthcare, manufacturing, telco, etc. And when we say telco, it's also 5G, because what we want here is the high-speed transmissions, and that means you have edge clouds or telco edge clouds very close to where your receivers are, and that way you can give very high bandwidth at very low latency, enabling a whole new slew of applications such as augmented reality and virtual reality. One fine day we might even be able to do surgery through remote means. So what kind of applications are we looking at? And it spans agriculture, finance, retail. In the retail space, and there's a lot of activity there. There's something called an open retail initiative. They want to scan items. They want smart shelves. They want to see if there's any theft. They want to be able to check you out sooner. And even in India now, we're seeing more and more malls. So this is up and coming and, very today kind of thing. But we also have a need for IoT in remote places such as oil rigs and power lines where it might be hard to go and investigate if there's a fault, if there's a broken line or something. What if you could just fly a drone over there and say, hey, there is a cut cable here, or there's some degradation because of a storm or tornado and it needs repair. So that's another space where you can use IoT in remote regions where it's hard to go, where you can have some storage and maybe some communication via satellite, such as from an oil rig. Surveillance, it's just growing and growing, at least at 25% CAGR. And my own home has a Ring doorbell. I mean, I can see who comes and goes and, who's left a packet for me type of stuff and whether I want to answer the door. And yet another very important thing is supply chain, whether it's for food or your vaccines, as we're, dealing with COVID and, supplying vaccines to countries that are
Malini, you are on mute.
Malini is
We're not able to hear you.
yeah.
Just a minute. Something happened. Give a second. Ask to unmute. Unmute yourself.
me. Hi, I'm unmuted now.
Yeah.
Okay. That was mischief that Prakash did. Okay. He
No,
muted
no. What
everyone.
happened is okay, let me explain you. I tried to get.
You caught him right,
It's
Malini.
okay. It's okay. So I've been involved with a few IoT projects. They were more like POCs. And why I want to share that is for the student population, that just anybody can get their hands on these. The hardware is not that expensive. You can get hold of a Raspberry Pi, which is about $30 or so. Even in Indian rupees, that's not too bad from your graduate school or undergrad school. And this particular project that I got involved with was like, what can I do with a car? What if I got a little OBD sensor in it? That's an onboard diagnostic center, and connected it into the dashboard. It's very standard technology, more than 20, 30 years old, and collect the information from there onto a little Raspberry Pi. I could detect where I was, how fast I was driving, whether I'm braking hard, and we can use some domain knowledge like, are you riding in a, in a busy area, or are you on a freeway? And from this sort of knowledge, you can create multiple apps, such as an insurance app, should the premium increase, a smart city app, like where are we stuck? And that might be an indication of how we might want to change some traffic lights, or the timing of the lights, or is it accident prone, or is it rush hour traffic? And sometimes you just want to know how many miles you drove, if you have like a travel tool app in your office or something, to see how many miles or kilometers to charge them. And this was just from one setup, your OBD sensor and some like little Bluetooth communication and then a Raspberry Pi, but 3 different applications are possible. Okay. And what are the aspects involved in this? And this is a pattern you'll see in all your IoT apps is there's going to be some configuration, who's driving, where they're driving, and what are the rates over there, some domain knowledge, some storage, because you cannot assume always continuous connectivity, and then some rules engine. And the rules engine is important for you to have low latency. Okay. Well, why are my slides not going forward? Okay, finally did it. Another one I'm involved with is with renewable energies. In California, where I live, we have a lot of sunlight, and it starts in the morning, goes up to evening, and especially in the summer, it can go as late as 8 p.m. But what happens in terms of consumption? This is Silicon Valley for the US, right? So there's a lot of consumption of energy starting around like 6 p.m. People come home, they put their lights on, put their air conditioners on. So what happens is you have demand and you have production, that's the renewable energy, and they're not in sync. And something that could benefit here is shifting load. Can I save the energy during the daytime to a battery and then transfer it and use it at night when people come home, whether it's to charge their cars or whatever? And in that space now we're working with Stanford, and they're right next to where I work, and they're interested in battery technologies. We're interested in a microgrid. And this is the kind of prototype we have in mind on our VMware campus. We're going to be monitoring the electric vehicles that are coming on campus and their charging. We have some data centers on campus. And if there is some kind of power glitch or constraint, like recently when we had wildfires, how we might curtail the consumption of electricity. And then we have some buildings and we can monitor the load there. We can monitor the usage and reduce something like 1 degree less or more when it's heating or cooling to reduce our consumption. So we're connecting all these, we're making a microgrid. And then if we have a central grid that says, look, we're suffering or we need to shed load, we can collaborate and use that signal from them and reduce our consumption or bounce back our consumption. And we could even sell them, or at least initially just share with them the extra capacity we have that we might have saved in a battery. So these are the two IoT projects I've been involved with. And this whole talk was slated as cloud, IoT, and edge. And let's briefly look at why edge. Edge is because we want to be close to where the data source is. We've all met the cloud. We've seen OpenStack, we've seen Kubernetes, we've heard all those terms, but they can be pretty distant, and those affect your latency to respond. And that's why earlier on I said you want some smarts at that edge, some rules. So you can say, hey, is the temperature too high? Then turn on some thermostat or turn on some cooler or whatever. Or if somebody's speeding, then at least give them an alert message saying, hey, you're speeding or you're crossing some lines. And that's the power of having some processing at the edge to reduce your latency. It also reduces your network bandwidth needs. And what does all this do? It introduces new problems because your compute is more remote. You have to deal with orchestration and update across maybe a unreliable channel or a slow channel. So if you had timeouts, you have to make them longer. Security is also a big issue when things are far and remote. And we weren't supposed to jump back. And intermittent connectivity, like I mentioned, if you were in a vehicle. Like one time I was driving in canyon space, we just don't have connectivity. So you don't want your remote autonomous driving kind of stuff to rely on something in the cloud. You want all your smarts local. So with that, how does a typical IoT architecture look like? You have devices at the bottom. Those are the ones that are collecting information. They can be sensors, they can be actuators too. So, they can do some action like opening some valve or changing the temperature settings. Then you have an edge or a hub, as we call it, or a gateway where some more processing happens, some aggregation happens. And finally, you might be transmitting data up into a cloud. And even if you're looking at something like a collection of wind turbines, each wind turbine might collect some wind energy and, make some current out of it. But where do you need the cloud or a more central aggregator kind of thing is because the wind farm collectively has to collect more energy. It's not the case that you want to optimize on a per, wind wind tunnel type of thing. If you're looking into the IoT edge space, what kind of applications will you make? You can make applications that are domain specific. So let's say it was the car case or the wind case or the battery case or a healthcare app. So those are applications that are domain specific. And then there's the other stuff that is agnostic of the application. And what do those mean? They have to deal with security. They have to deal with monitoring and management. And those don't have anything that is specific to a domain. You still need to be able to update your applications. You need to sign them for security. You need to check how you register a new device and whether it's legitimate, whether it's allowed to, and what roles and access capabilities it has, and things like storage so that you can save the data, you can transmit it when it exists. So a whole slew of software that is parallel to the domain kind of applications. And what else do we have? We have other related applications, uh, and application specific. You have things like Kubernetes to give you cloud support. You have Service Mesh to help you do some networking, and sidecar kind of applications like logging and RBAC that Gansham also mentioned. You have blockchains, especially when you're doing supply chain. Did the vaccine arrive safely? Was it held at the right temperature throughout its process? And then with every application that you have a device, and was anything tampered on that device? Did somebody change some firmware? Did they introduce a rootkit into it? So that's where a hardware root of trust matters, and then securing your keys inside that trusted hardware, and also encrypting all your data that is remote, because more insecurities when things are not under lock and key in a data center. So you want to have all your disks encrypted. And last but not least, you'll encounter machine learning everywhere. So for me, one of the most wonderful things about IoT is everything in your software stack, every tool in your experience bag comes into play here, because it involves networking, storage, compute, machine learning, hardware root of trust. So anything you do is useful in this space. Any experience you have is useful in this space. And what this picture is showing us is we'll have maybe edge clusters or edge clouds, because you can't rely on maybe one single Raspberry Pi to do anything, because these are remote. What if they break down? So that's where the value of having a little edge cloud comes in. And of course, it's a price point thing. My Ring doorbell has only one little sensor there, but for more expensive, high value applications, you'll have an edge cluster, you'll have some high availability, you'll have some fault tolerance with maybe more than one sensor, and different ways to, monitor and manage them. And how do you communicate to your clouds? They could be through messaging fabric, they could be just through Ethernet, or they could be through Wi-Fi. So there are multiple options even there. And why did we mention open source? Because it can help you jumpstart your journey. And there's several foundations, not just our OpenStack and Open Infra. There's the Linux Foundation, there's the Eclipse Foundation, there's the Apache Foundation. So mix and match, as a student, as an entrepreneur, as an academician, you might want to look at these different foundations to see if there's a project that's relevant to you, or even among your own ideas and projects where you might want to contribute. They're all, good open source foundations, and they all have different degrees of, community and adoption, and some things fit better in some places. So you might want to shop around. Okay. Another reason why, whether you're an entrepreneur or student, you want to go the open source route, which I'm sure you all already know because you're part of this meeting today, is it helps you jumpstart. It doesn't lock you into any vendor. It's also your innovation horizon. A lot of new things come in open source first, so that people can check the temperature and see how much interest there is in this community for something. And your own solution, you're going to differentiate. And it gives you some standards too, some API standards. And this is a little more about the different foundations. And one of the things I particularly like is with the Eclipse Foundation, they have a digital twin project that's got quite some usage. They have IO Fog too. And with the Linux Foundation, you have EdgeX Foundry, a project that I have been involved with. And as Prakash mentioned, I've been involved in open source for several years, and most recently in EdgeX Foundry. And I even served as a security work group co-chair. There are other projects there, and Open Horizon is one of them for management and monitoring. So that's this guy out here. And there's Edge Virtualization Engine, Eve, which is trying to bring a notion of an edge that can be a virtual machine, it can be a container, it can be just bare metal, and that's their notion of edge virtualization. And other virtualization engines connect up with it. Okay, with that, a little look at a eye chart. This is the EdgeX Foundry architecture diagram. You'll note at the bottom that there's several sensors it can connect with. And why? Because it supports multiple connection protocols such as Bluetooth, MQTT, SNMP, and your usual REST and Modbus. So that's the power of this project. One of the reasons why I started working on it is like, this is common CRUD work. I mean, everybody needs to do it, grunt work, a lot of protocol connections. And then you want some kind of rules engine, some alerting mechanism, logging. So that's what EdgeX brings, all this infrastructure, and then you can focus on your domain stuff. And why did it go into this mode? Okay, here we go. So EdgeX Foundry has now got some adoption in China, in US, and even some companies in India. And if you're interested in kind of like jump starting a project and getting some of the southbound connectivity in place and then just moving from there, this is a very good project to get started. It's all containerized. It's got a relatively small footprint, so you can drop it into a Kubernetes cluster too and get started. This is Open Horizon, which provides you some monitoring and management capability, because after all, after you've installed those edges, you want to know what they're doing. You want to be able to update them and so on and so forth. This is a project from IBM contributed by them. So now let's just take a look at what's happening in India. India is just an amazing country, not just because I came from there and we have all come from there and we're all there. It's because we as a country have so many educational institutions. We have some of the brightest minds there, and they're also very innovative, hardworking. And Gansham also mentioned this, we don't have a language barrier. Most of us know English. So it's very easy for us to get into technology. And that's evidenced also by the fact that, with all that IITs and NTTs and innumerable number of universities and our footprint in this technical space, that we have so many startups. And I was just looking at the 2019 kind of startups. There was already 15,000 of them. And if anything, it might be 3,000 right now. I mean, it's just like 2x or way more. And the beauty of it is it's your imagination, what kind of applications you're looking at. Some people want to look at water conservation. So I'm one of those sustainability type of things. So that's why you see me choosing this as an app. Then electric vehicles. In India, we have so many scooters, autos, cars, etc. So I think we all desire electric vehicles for a cleaner energy, for a cleaner air. And there have been efforts in that space too, including a recent hackathon that VMware was sponsoring and saying, hey, how do we adopt EV? How do we make that happen? And there's a funny story to that. I really believe in electric vehicles. I still don't have one though. That I said, let's see how many people come and use it, how much they charge. And then if there is a power crunch, how do I curtail a vehicle that doesn't have to drive much? I mean, let's push it and then get the next vehicle on there to start charging. And COVID happened and nobody's driving to office. So it's all a big flat line right now. But a few links over there. So if you're a student, I would suggest you play with these tools, the software, and just do something you're excited about. It really doesn't matter. It's affordable to get your hands on. It's not as expensive as buying an Intel Xeon server, okay? And do things that make sense for you, what you're passionate about. So with that, I would say, let's start solving some real problems. And some of the problems I can think of are like air pollution, energy consumption. The US really spends too much of it. And in India, we're spending a lot too, but not as badly. But we really have to conserve air quality in India. We have to conserve our water because our water table is going down. And every year when you travel to Delhi, you can see the air pollution there. And it doesn't help that the farmers are burning their stubble and things like that. But what can they do? Maybe they shouldn't grow a certain crop somewhere, or maybe they shouldn't water when they don't need to, or maybe they shouldn't over fertilize. So IoT in agriculture is super, super, valuable. And in the US, they've used it for things like very expensive crops like wine. They monitor the soil moisture. They determine when to water the crops, because if you water it too often, the sweetness of the grapes goes. If you don't water it enough, then they dry out. So it's a very expensive crop, and it's worth this effort. And I think we can do it in India, not because of its wine and expense, but because you don't want to waste fertilizer. Even some things like when you apply urea depends upon what the moisture in the air is. You don't want to apply it when there's no rain, but when there is Im- impending rain, that's the best, because that helps fix your nitrogen. So an IoT app doesn't just have to like sense something from the environment, but it can also take input from other sources like the weather bureau. And something very today is, let's say you're near the metro station. How many people are wearing masks? Who should be alerted about this or reminded to wear a mask? And in India, something I noticed recently is how people wear a mask. It can be under your chin, it can be on your mouth and nose, or it can be just over your mouth, sometimes over your mouth and nose, and suddenly somebody pulls it down because they want to talk. So things like this can become like educational, or when people are passing by, it can be an alert and a beep and say, please wear your mask. So this would be an IoT application that leverages machine learning for face detection, for mask detection, and then some actuation through a voice monitor kind of thing, saying a microphone saying, hey, you're not wearing your mask right. And I had fun making this little Wordle picture, but what I want to point out is our IoT edge vision. The story contains all parts. It contains the cloud, it contains the edges, it contains hardware, a mix of hardware supporting different protocols. And whether we use message passing or whether we use, just uh, TCP, IP, and whatever, it has everything involved in it. And why we have such a potential here is because Indians are entrepreneurs, they're innovators, they're hardworking, they have no language barriers, and we are getting our, feet and hands and all deeper and deeper into open source, so we can leverage all of that, and we can mold these projects to meet our needs and push them in the direction we want, and that's the power of open source. And with that, thank you. And I think we should be back on target with time, with 2 minutes to spare.
So go ahead. Anybody wants to ask Malini any questions? She has been gracious in cutting her time short, at the same time conveying what we needed to hear. So anybody? Go ahead. Krishna, you need to ask something. You're from Bangalore, right? You're not curious about it?
Krishna is putting you on the spot. Don't worry. We can always chat by email later. And on one of the slides where we had the, little OBD sensor thing, I've given a link for some sample code in Python. How you can use an OBD sensor. It was like part of an early lecture that I developed.
No, good overall, good presentation. I will connect later. Thanks.
Okay.
Onboard diagnostic. Okay, I
Thank
think
you.
since there are no further questions, I will just thank Malini for taking the occasion to put down. She just flew from India, so I can see all the Indianness of all the projects she's referring to. And certainly, it's always inspiring when you go and come back, you see, oh, what a change. In this 20 years, I think it has turned upside down. And definitely, and same is with China, okay? It's no different. They are also same way. 2003 to 2020, they are just upside. And as we say, the water flows. So the dollar flows from US to China and India now. People like it or dislike. Okay, thank you, Malini, for this good
You're
show.
welcome. Thank
I
you.
will stop recording for yours, and hopefully people will hear that and they will draw their conclusions. I'll stop recording for you. Thanks.